Well, especially if you have multiple events on
All right, so in this particular question, if you notice, they're basically giving you two
No,
pairs
no, I get
of
that.
information, and we're really focusing on just the differences. So if you notice, what I did was here in column C, as I'm highlighting it for you, I put in the values as shown in the chart, and I averaged them. So this is the average of the values. Let me give this a color so it could stick out for you. So let's call this a little orange, and give this a little shade of orange as well. So you can at least follow where I'm going with this. Okay, so there's your average of all of these. And you have your standard deviation as well. That's what SD stands for. Sample size of 12, obviously 1 to 12, and degrees of freedom, obviously 11. Now I've already pre-programmed this for you, and so I want to show you that this actually will help you in the calculation, because it is a lot of numbers, and then you can turn around and transition yourself in using any other method you want to use regardless. So if I were to show you the results here, once they average this, notice that they say process 1 minus process 2. So they're subtracting down, hence why the negative 23. So 84 minus 107 is negative 23. And so the mu sub d, and in this case, would be equal to 0 or less than 0 for the alternative hypothesis. Your degree of freedom, obviously 11. You're using a t-test. And as you can see, there is the calculation based on the numbers. Look over here in the green, or right here where I'm pointing with this cursor, right? You see how this says negative 3.675. So basically this is the formula embedded in here. Have you noticed the formula parts? So for example, this is 14.216. There's your square root of 12. The average of these two is this number here. And you can see that in the Excel sheet. And then we average these two numbers, the negative 15 and the 4. And that's how we get negative 3.67555. You also see the critical value based on your degrees of freedom. So 11 degrees of freedom at a 0.05 level of significance gives us a negative 1.796. Now again, I'm going to do a little favor for you here. Let me see if I can scrunch this in. Oop, wrong one. Go here. I'm going to go to the home number. I'm going to smush it in. There you go. And so there's your critical value. And now there is a notation in the answers. As you can see, everything matches up. I did not give you a p-value here. I should though. Let me see if I can master up a p-value for the next one. But this is your critical value. It's already, as you can see in part D. This is your part D right here. I'm going to just highlight this real quick so you can see it. That's part D. This is your part C. I don't know what I just did. Just trying to highlight it. There you go. And then the last thing you need to do is define, in this case, at the 0.05 level of significance, can the company conclude that the mean assembly time for process 1 exceeds that of process 2? And in this case, you would say yes. All right, and again, there's the rest of the question. I'll bring it down so you can just look at it for a moment and make sense of why this question reads the way it does. All right, so this is the nature of the question right here. And you can pause this video at any point. All right, let me pull up another question. Let's take a look at another question here. And so what's really cool about these is you can just use the difference, just a column for the differences. In this case, we only have 10, so I'm glad that this came up, because this is the next one I'm going to show you. So notice that this is 0.18, 0.06, 0, negative 0. This is going crazy. Negative 0.04, 0.05, 0.19, 0.32, 0.23, 0 again, and then 0.19. Now at this point, you notice you have 11 and 12 from the last one, right? So all you need to do is delete. All right, and this is going to change to 10, and 10 minus 1 is 9. That's your degrees of freedom. You need to change these because these are built into, for example, this answer here. You notice it's 3.16 right now, as it was before with the 12 here. It changes to 3.464. So this number has to be changed to the sample size. Notice that the 11 and 12 are just blanks now. Okay, based on this, we have a critical value. We have an actual t-value. So there it is right there. So I'm just going to go into the explanation real quick. If you look at the calculation, this is 3.12. If we round it, it's supposed to be 3.136. I'm trying to figure out why. Is it rounding? Yes, it's rounding. So if I change this number and I round it, so let me go back to the home page. Just go to number. I'm going to shorten this. Okay, and hit enter. That should be what I need because they're dividing 0.118 minus 0. And they're dividing that into 0.119. So that answer should now be changed. Let's see why it's not changing. 0.119. This should be the square root of this number. And that's giving us those two numbers. So there is a slight rounding issue here. I'm noticing that happened in the previous problem. I don't know if you noticed. In this case, the critical value, it actually should be 1.1833. Let's see what's going on here. F inverse of F, 24. Okay, so our degree of freedom is 9. And our alpha, in this case, is a two-tailed, yes, so it should be 0.05. Yeah, so this just does react correctly. I'm wondering if the issue in both of those questions actually has to do with the denominator value. Because when I do it in the calculator, I obtain 3.136, but I'm also making it short. Let's take a look. Let's play with this number here real quick. The square root of 10. So I'm going to go to equals SQRT. Let's add this to your sheet. Square root of 10, and I'm going to simplify this. Let me see if it makes a difference. I have a feeling it's gonna. We want to actually shorten this. Let's make it 3 decimals. Okay, so this is now going to be equal to this number. Okay, does it make a difference is the question. What if I change it to 3.2? Will it make a difference? Yes, it comes better, comes closer. Let's see, 3.126. Let's make it 3.13. No. Okay. Let's go back to, 3.16 is what I said, 3.16. If you put it at 3.16, it rounds out to 3.123. 122. I'm trying, still not exactly giving us the number we're looking for. And if I do it manually, so what if I use the formula up here and I said, okay, 0.118 minus 0, which who cares, right? And we're dividing that by 0.119 divided by the square root of 10. So basically it's that formula. Okay, so I'm going to come up here. And I'm going to say equals, and I'm going to come up here, and I'm going to say equals. The square root is not reacting. Let's see, SQRT. Double click, and there's my 10, which I'm eventually going to switch out for a number. Again, if you look at the number here, I have 0.037631, and over here, I have 0.0378. So let's see what the difference is. So worst case scenario, you can tell that you're going to basically have to play the rounding game with some of these. And there you are. There is your 3 point. It is rounding. That's the issue. All right. So if this helps you, what I'm going to do is I'm going to leave this here as an example that when it comes to this, to add to your insult, you have to actually address the rounding issue. All right, and so what you'll do, just to remind yourself, double click on this, you'll see that that is given to us here. That's no change, right? And if you double click on here, you'll notice that this is simply 0.119 divided by square root of 10. And technically, I'm not rounding this one. So let me just open this up one more time, because if that worked, this should work. Because this is simply square root of 10. Right here. Let's see. This is equal to SQRT, square root of 10. Interesting. And when we divide these two, this should give us equals this number divided by this number. No. Slight difference there, isn't there? Huh? So take a look at the formula I used there. Maybe that'll help you make a decision. All right, so we have this to use as a template. Let me go back to Alex and let's talk about other examples. All right, back to Alex. Alex, where are you? Oh, not that one. All right, so the next question that we have to talk about is this one. This question has to do with the mean difference of populations. We're looking with, in this case, a t-test with equal variances. All right, so I have programmed one more part of this lesson. This is the third example that they give you. This is a hypothesis test for the difference of population means as a t-test for populations with equal variances. So when you look at this, don't freak out, because I'm giving you a template that should work without a hitch. There's no rounding issues or anything here. So we read the question, we pick out what's important. So if you notice, in this case, it took out 2 samples of plants using electricity and plants using gas in terms of a fuel, okay? These samples consisted of 12 plants using electricity. So let's call that our N1. So I'm going to begin with N1. I'm going to put in a 12 here. My N2 is 9. I'm reading ahead. It says 9 plants using gas. X bar, which is the mean that we found in this case for the 12 plants, was 47.55. Notice that I said to you in the Excel sheet, only change the yellow cells. You have a standard deviation for the first value of 7.75. And according to this, you have a mean of 5760. So go back to your X bar, 57.60, with a standard deviation of 8.11. And so there are all of your values. Everything is calculated. This is all of the calculations you'll need. This is your degrees of freedom, because you're going to add these two together to get 21 minus 2, leaves you with 19. In this formula, we use the standard deviation squared. So it's like a corrective measure we use, where we take the standard deviation of both, calculated to be at 62.46654, which that's the formulation. I'll talk you through it in a minute. And so let me tell you what each of these means. So you obviously know sample size 1 and 2. You understand x bar 1 and 2. In this formula, you see we use this 1 over n1. And that's because this SP, S squared P, has this formulation where it's basically the n1 minus 1 times n2 minus 1. At the very bottom of this formula, because you're going to start with x bar 1 minus x bar 2, and this minus 0, and you're going to divide this by this S squared P times 1 over n1 plus 1 over n2. So I've already done this for you. There's your SP squared, right? That's already done. This part of the formula is already done as well. This is part, the 1 over n1, n2 added together. So if you notice, I also squared your standard deviations, and that's used in the formula to calculate the t-value. Okay, that in itself is all of this. Basically, all of this formula is what you will have in here. And that's why we simplify it, to make our lives a little more tolerable when we do this type of math. So just remember, this is the square root of all of this. All right. And when calculated, your t-value is negative 2.884. You'll find your critical t-values the same way as well. So let me go over here to the critical t based on this question. In this question, you'll notice that you have alpha value for your critical t. What's your alpha value in this question? I didn't think I missed it. Let me go back up. Oh, 0.05 level of significance. So for your critical value, you're going to take the 0.05. Okay, so let's do this. Let's call this critical value. And I'm going to do the 1 tail on this side and the 2 tail on this side. Okay, so if the critical value in this case happens to be 0.05, which you can change, it's going to be based on, I'll make this yellow so you can remember that yes, you can change this. You'll have to. In this case, our 1 tail will be equal to that number. Our 2 tail will be equal to that number divided by 2. 0.025, which in this case it's a 2 tail because they're asking us for difference versus the same. All right, so to find the actual critical region, you're going to go equals t dot inverse, double click on that, your probability 0.025, and your degree of freedom, which I found for you here, is 19. All right, and so we do get 2.093, and that's what they get. Remember, it's the plus and minus of this when it's two-tailed. I should have actually done this on this side. Equals t dot inverse. And you can always click on it and double click on the cell as long as you don't change it. And if you do make a mistake, I can show you how to fix it. So this will be the plus, and this will be the plus and minus of this number. Let me see. There you go. So that whenever they ask for the critical two-tail, there's a plus and a minus answer. All you have to do is change the cell. Only change the yellow cells, right? We don't change anything else. All right. So then the other issue that you would want here in this case, because remember the rules of thumb that I said to you, if P is less than alpha, let me go back here to draw. So if P is less than alpha, we're going to reject the null. If the OV is greater than the CV, we fail to reject the null. So keep in mind in this case, the null hypothesis, so let's go back here, your null, your HO, is simply that mu1, you can say mu1 minus mu2 is equal to 0. And if your alternative in this case would be mu1 minus mu2 is not equal to 0. Remember, this is a subscript, so don't go back to the previous lessons. Since this is the case, can we conclude that the mean cost per unit per plants differs? So it differs. That means that we're going to reject a null, and therefore yes. You could see that our OV is greater than our CV. OV greater than CV. We're going to reject the null. Therefore, yes, this is different. It differs. Okay? So that's this type of lesson. Again, I'll give you this to look at. Just take a moment. You can pause the video as you look at this. So let me open it up so you can see everything. Pause the video as you need. Just understand that you don't have to go through all of that calculation. If you wish, you can. My concern is that you miss a step in order of operations, and it's not a matter of you using the wrong formula, it's just on our order of operations. And that's the actual question. You can always pause and stop and go forward and so on. All right, good. So far, so good. Okay, in this final calculation, what we have is a difference of proportions. And remember, when it comes to proportions, you're really just looking for N1, X1. If you could fill in N1, X1 into a calculator, Excel sheet, or any other value, once you have the formulas, which I already made for you in the little teal, or not teal, in the orange-ish color, right? What you're going to do then is you're going to use those values to solve. So for example, if I read this question, they're talking about 2 flights and they're looking at random samples, 2 random samples. So if I look at N1, X1, and I look at N2, X2, I get my proportions or my p-hat. So my N1 looks like it's 285. And in this example, my N2 is 243. They go on to tell you that you have 36 of the 285 had overweight items, and here 42 out of the 243 were overweight. Notice how everything else just came to life. You have your Z value right here. You have everything you need, pretty much. It looks like carry your intermediate computations to 3 or more decimals. And as far as the formulas are, I embedded them in there for you in the pinkish or orange, whatever color you want to call it. All right, so since they want 3 decimals or more, I would assume this is just about what they want. Let me see what happens if I round this, because the actual value that I'm supposed to obtain here is negative 1.516. So what I want to do is let's look at the explanation real quick. It looks like they're carrying out the different computations to about 3 decimal places. Let's see why this is not changing. I could fix that real quick. All right, so yeah, it looks like it's, let's see what's going on here. So notice what it says, and this is exactly what's happening. You see how I'm obtaining negative 1.50049. Here it's saying the value negative 1.516 above is obtained after intermediate computations are rounded to 3 decimal places. So let's round everything to 3 decimal places and watch what's going to happen. We should end up with the same values they have. So I want to round everything to 3 decimal places. Go back out of there, go here. Okay, so that's 3 decimal places. This will be 3 decimal places also. I'm going to go here to the home page and I'm going to also correct this. All right, so now these values, so this should be B13 plus B14 B13 plus B14 divided by B10 plus B11. So you end up with 0.148, which is what I have here. This should be equal to whatever I obtain here. It does adjust a little bit. And so I'm getting negative 1.5016. So I'm wondering if there is possibly a typo in Alex. It says here we would obtain approximately negative 1.502. Either value is taken as correct. For consistency, we will use the value negative 1.516. So what they're saying is that the calculation I have is correct, but they prefer this if we round everything to 3 decimal places. So let me, just for the sake of doing the example, do the z-test here. So here's 1.26 minus 0.173 minus 0, so it doesn't really matter, right? And then we're dividing that by the square root of 0.148. I'm not computing this or setting this up as a okay, and we're going to divide that by 1 over, I'm just going to use these two, 1 over 285 plus 1 over 243, and that's what I'm getting. All right, since I went ahead and calculated that, I'm going to go ahead and do this as well. Let's see what we get. Okay. So if I divide equals this divided by this number down here, I get a very big number, and that makes absolutely no sense. Why is that? Let me do another parentheses. That could be what's missing, because it's only doing partial of the square root. There you go. Yeah. So take a look at this. If you noticed, I actually did the question again. You can always click on these cells and you can look at the formula if you want to play with this and really learn how to set up the formula. But these are 2 different z-scores using the same new numbers. So let's take a look again at what the difference is. Again, all I had to do was identify this, everything else came up. What I want is a z-score. The process for finding the critical value does not change. It's the same critical value or the same method we use. Or we look at one-tailed, two-tailed, that kind of thing. All right, so let's take a look one more time at this formula. Look at what I have. Look at my result, same as this. Where I differ is here. And I differ by a nothing. If you notice, this is 0.0310. This is this computation here. You may want to decide to use this denominator instead, which we can just change it. I can just change it here. So this won't be B17 anymore. All right, and let's see what happens in our calculation here. Does it change anything or no? It doesn't look like it changes anything. Let me just double check that formula one more time. So it's going to be, okay, so I'm going to come over here and I'm going to switch this out. So where this is going to be D10 times D11. No, that didn't work. Okay, so let's try this one more time. Okay, so this is going to be the square root of B10 times B11 plus, I don't know why this is still not recognizing the value, B20, I'm sorry, B20, B21, my mistake, B20 and B21 plus D20 is D20, D21. All right, let's see, still giving me a reference issue. This is column B, so 0.148 times its complement plus, okay, I'm sorry, this should be D10 minus D11. All right, that should be correct. And let's see what is the issue with the square root. It's still giving me a reference issue. I don't understand why. Let me start from scratch. Square root of this value times this value in parentheses plus the 1 over 12, I'm sorry, the 1 over 285 plus the 1 over 243, close that parentheses. I'm actually going to do double parentheses here. So let me go out here, make a parentheses, and all the way in here, and put another parentheses equals. There you go. Oh yeah, no. And now this will be equal to this value divided by this value. Something is not clicking correctly here. Let me see if I can figure it out. Okay, it just seems to be a rounding issue. So here you are. You have two values to peruse and make sense of. That's one set. That's the one I would use once calculated. This is the one that comes out of the formula, but it's questionable. But you can still use this as to verify your answers. My suggestion is use this as a tool to help you and make sense of this, if anything. And then as you read the question, you'll understand why it is that I say focus on specifics in the formula. I'm going to send you some links as well, so hang tight.